This video will cover some of the algebra topics that can appear on the Math TSIA. Take a moment to look at these words. If there are any words that you're unfamiliar with, look at their definitions and make connections. Equations versus expressions. Equations can be manipulated using the properties of equality with the goal of solving them, such as 3 plus x equals 10. Expressions can be manipulated in different ways with the goal of putting them in different forms. For example, we have 3 parentheses x plus 2. If you distribute those, it's the same thing as 3x plus 6. Expressions do not have a relation symbol, and equations do. It has an equal sign right here. Solving linear equation word problems. Many real-world scenarios can be demonstrated using linear models. They usually require finding an initial value, the y-intercept, and the rate of change, the slope. For example, suppose a car is traveling at a rate of 50 miles per hour. How long does it take to travel 120 miles? If y is miles traveled and x is hours traveled, then the model is y equals 50 times x. In this case, we know that y is 120 miles, so we'll have 120 equals 50 times x. To solve for x, we have to divide both sides by 50. Divide each side by 50. And they have x equals 120 divided by 50, or 2.4 hours. Try this one. A helicopter initially hovering 40 feet above the ground begins to gain altitude at a rate of 21 feet per second. Which of the following functions represents the helicopter's altitude above the ground, y, in feet, t seconds after the helicopter begins to gain altitude? Pause the video and try this question. When you're ready to move on, unpause and then check the solution. Choice B is correct. It's given that the helicopter's initial height is 40 feet above the ground, and that when the helicopter's altitude begins to increase, it increases at a rate of 21 feet per second. Therefore, the altitude gains t seconds after the helicopter begins rising is represented by the expression 21t. Adding this expression to the helicopter's initial height gives the helicopter's altitude above the ground, y, in feet, t seconds after the helicopter begins to gain altitude. Y equals 4t plus 21t. Choice A is incorrect. This is the helicopter's altitude above ground 1 second after it began to gain altitude, not t seconds after it began to gain altitude. Choice C is incorrect because adding the expression negative 21t makes this function represent a decrease in altitude. Choice D is incorrect and is the result of using the initial height of 40 feet as the rate at which the helicopter's altitude increases per second and the rate 21 feet per second as the initial height. Using this model, how high would the helicopter be after 10 seconds? For 10 seconds, we're going to say that t is now going to equal 10. and we're going to evaluate 40 plus 21 times 10. 40 plus 210, that equals 250 feet. Solving for y. To solve for something, you must isolate it. Get the specified variable by itself with no other duplicate variables on the other side. To do this, you'll need to perform inverse order of operations. Add or subtract, multiply or divide, exponents or roots or logs or trig, parentheses or brackets. So it's just reverse PEMDAS. Example, solve 4x plus 2y equals 8 for y. First, we will subtract 4x from each side. Rewrite it. 2y equals 8 minus 4x. Divide each side by 2. Simplify the fractions so it becomes y equals 4 minus 2x. Reorder to put it into the form y equals mx plus b. So y equals negative 2x plus 4. The m represents the slope, and the b represents the y part of the y-intercept. Try this example. Solving for y. Which equation is equivalent to 4x minus 3y equals 15 when it is solved for y? Pause the video and try this one out. The correct answer is answer choice A. Solving linear inequalities. Solving inequalities is similar to solving equations except for some additions. There could be 3 sides instead of 2, and when dividing or multiplying by a negative number, the inequality sign will flip. When you have inequalities in word problems, you'll see words such as these. We have less than, fewer, below for the less than words. Then we have greater than, exceeding, above for the greater than sign words. We have less than or equal to, at most, and no more than for this symbol. And then for this symbol, we have greater than or equal to, at least, and no smaller than. Example, consider the following linear inequality. Negative 3y minus 1 is greater than or equal to 2x plus 2. To solve, begin by isolating to the y. So let's add 1 to each side and rewrite it. Divide each term by negative 3. When you divide by a negative, you flip that inequality sign. You get y is less than equal to negative 2/3 x minus 1. The graph would look like this. To start off the graph, plot the y-intercept, which in this case is 0, -1. From there, we know that it's a solid line since it has a equal to sign on it. So it's the equal to part that makes it solid. If it didn't have the equal to part, it would be a dashed line. From there, you'll use the slope to plot some more points. It has -2/3, so we're going to go down 2 and then right 3, or up 2, and left 3. We'll do each one starting at that initial value, the y-intercept. Right, let's go down 2, right 3. And then let's start get the initial value, up 2, and then left 3. From there, you just connect the points to make the line. Now, it's shaded below the y-intercept because it has a less than equal to sign with the y in front of it. So as y is less than or equal to, it's shaded below the y-intercept, and when y is greater than or equal to, it would be shaded above the y-intercept. Try solving this one in the space here. Draw this on your paper. Circle your answer choice, and then check with the video. Okay, to solve this one, first let's go ahead and add the 1 to each side. We have negative 2x is greater than negative 3x plus 9. Add the 3x to each side. And then we have x is greater than 9. So it can't be B, can't be D, those are 7s. Now A and C, neither of them look exactly like this. This one is x is less than 9. This one is also the same thing as x is greater than 9. If you were to change it to the answer choice, we can subtract the x, subtract the 9, and then divide by negative 1 to get rid of that negative sign. We flip the sign because we divide by negative, and so you would get answer choice A. Solving systems using substitution. In one equation, solve for a variable. Plug in the expression that was solved for in place of the variable in the second equation. For example, the system x plus y equals 5 and x minus 2y equals negative 2 will be solved by substitution. This will be substituted into the second equation for x. So instead of this x, we put this entire thing in there instead. 5 minus y minus 2y is 2. Now we're going to solve for the y. Alright, so combine the like terms. That gives you negative 3y. Subtract the 5 from each side. We get negative 3y equals negative 3. Divide each side by negative 3, and then you get y equals 1. Now once you get that answer, you're going to substitute this value back into the first equation to solve for the x. So we have x equals 5 minus 1, x equals 4. If we start from the very beginning of the equation, we would have this step, and then you subtract the 1 from each side. The solution to the system is x equals 4 and y equals 1. These values work in both equations. If you were to plug them back in to each equation, you'll get true statements. They'll be the same number on each side of the equation. Your ordered pair would be 4, 1. That is the intersection of those two lines. Solving systems using elimination. Eliminate one variable by combining a linear combination of two equations. In elimination, the equations are added or subtracted to eliminate one of the variables. An equation can be multiplied as well by something that's not 0. The goal is to get coefficients of the same variable to be the same or opposite in both equations. So using the same system from before, we're going to multiply the first equation by 2. So here's equation 1, equation 2. We're going to multiply it by 2. 2 times x is 2x, 2 times y is 2y, and 2 times 5 is 10. When you multiply the equation by 2, you multiply everything on both sides of the equation by that number. And then we just rewrite the other equation. Notice that the coefficient of y is opposite. If the equations are added, y will be eliminated. So we have 2x plus 1x equals 3x. And 2y minus 2y is 0y. They get eliminated. 10 plus 2 is 12. Divide each side by 3. X equals 4. Substitute this back into either equation to get y equals 1. Again, that ordered pair is 4, 1. That's the intersection of those two lines. Try this example. X plus y equals 0 and 3x minus 2y equals 10. Which of the following ordered pairs, x, y, satisfies the system of equations above? Pause the video and try this one out. When you're ready to check, unpause the video. The correct answer choice is B. Remember, we have answer choices such as these. You can also plug in each answer choice into the given equations to see if they're true for both equations. Evaluate functions. To evaluate any function is to substitute a given value or expression for the variable and simplify the result. Here's some examples. If f of x equals x squared minus 3x plus 11, evaluate f of 5. So wherever you see an x, now we're going to replace it with a 5. You get 21. Another example, if f of x equals 4x minus 27, evaluate f of 8. This time we're going to replace the x's with an 8. So the answer is 5. Then we're going to evaluate this one. If f of x equals the square root of 3x plus 1, evaluate f of 5. Plug in 5 wherever you see an x. The square root of 16 is 4. Okay, try this one. If f of x equals x squared minus 5x plus 3, evaluate f of negative 1. Pause the video and try this one first. Alright, to do this one, instead of x, we plug in negative 1. So 1 plus 5 plus 3. 9 is your answer. Now on this one, notice that this is not a negative 1 because negative 1 squared is really negative 1 times negative 1. The parentheses matter on this one. Exponential equations, word problems. If a certain quantity increases at a constant rate each time period, that is called exponential growth. For example, a savings account may grow by 1.25% each year. On the other hand, if a certain quantity decreases by a constant rate, each time period. That is called exponential decay. An example of that is the way the value of a computer may decrease at a rate of 20% per year. General procedure. Formulas for exponential growth or decay can be confusing because depending on where you run into the formulas, you'll see different variables and different arrangements used. For this example, we'll use these two versions. We have A equals A initial parentheses 1 plus R to the t power for exponential growth, and then A equals A naught times 1 minus R to the t power for exponential decay. Here's what each of the variables mean. The A represents the amount at the end of the period, or current amount. A initial is the beginning amount, initial value, also known as the principal amount. R is the rate of change in standard form. For example, 3% is 0.03 in standard form. The rate is positive if it's a growth, and it's negative if it's a decay. And then T is the number of time periods elapsed. Here's an example. Suppose you deposit $5,000 into an account that adds 1.6% interest every 3 months. What will be the value of the account in 7 years? This is a growth, so we're going to use this formula. The initial value is $5,000, and the rate as a standard form would be 0.016. Basically, we divide this by 100. It says every 3 months is 4 times a year. And over 7 years, that's 28 time periods. So 28 comes from 12 divided by 3 times the amount of years, which was 7. If we plug this in, and they would stop here if you're not able to use a calculator, you would get A is equal to $7,798. So if it was a calculator question, they would want you to find this. But if they did not have a calculator for that question, you could stop right here. Here's another example. If the value of a certain car decreases at a rate of 7% per year, what would it be worth after 4 years if it had $28,000 purchase price? Because the rate is constant each hour, this is an example of exponential decay, and we'll use the formula. The initial value is 28,000, the rate is 0.07, and T is equal to 4. Okay, then once we get this part right here, that's the formulating part. And then from there, you would put that in the calculator. Again, if it was a non-calculator question, you would just stop at the formulate stage. Try this one. Where you're eliminating answer choices, put an X on the answer that is the most incorrect, and maybe like a slash on one that you think might not be correct, but it's not as incorrect as that first one. Alright, a radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions f models the remaining amount of the substance in grams t years later? Pause the video and try this one. The correct answer is answer choice A. When it decreases, remember it's going to be 1 minus r, so it's 1 minus 0.13. That's 0.87. That's the only answer choice that has that inside of the parentheses. Remember, the parentheses is the base. That's the 1 minus the rate or plus the rate. And then the outside number is the initial value. Formulate expressions for verbal descriptions. Verbal description. 7 less than twice a number. 7 less means a minus 7. Twice a number, twice means 2 times. A number, we'll just call that x. They might also use n or any other letter that they would have in the answer choices. So your expression from this sentence is 2x minus 7. Manipulating radical expressions. Here are the rules that apply to simplify radical expressions. We have multiplication. The square root of a times the square root of b is the same thing as the square root of a times b. Such as the square root of 3 times the square root of 6 would equal the square root of 3 times 6, which would be the square root of 18. Division, we have the square root of a divided by the square root of b equals the square root of a over b. For example, if we have the square root of 6 over the square root of 3, that's the same thing as the square root of 6 over 3, which is equal to the square root of 2. Addition and subtraction. Radicals can be added or subtracted only if they have the same radicand. That's the number under the root symbol. So radicands would be the 2, it would be the 18. Now we could add those if you simplify this to make it, see if we could have it the same as this 2 right here. The square root of 18 can be broken down into the square root of 9 times the square root of 2. 3 square root 2. So if we had square root of 18 plus square root of 2, that could be rewritten as 3 square root 2 plus square root 2, and that's going to equal 4 square root of 2. Here's another example. Simplify the square root of 2 times the square root of 8 plus the square root of 10. You want to distribute that square root of 2 into both of these. We have square root of 16 plus square root of 20. I can break down. We have 4 plus 2 square root 5. And that can't be simplified anymore because 5 does not reduce anymore. And it's not the same as the 4. It doesn't even have a radicand in here. Let's look at another example. Add 5 square root of 12 plus 2 square root of 48. You want to simplify both of the radicals to get the same radicand. So square root 12, that could be square root of 4 times the square root of 3. And then square root of 48 is the same thing as the square root of 16 times the square root of 3. Square root of 4 is 2, and then we have square root of 3. This one is 4 square root of 3. Now they have the same radicand. They're both 3's. So then we have 10 square root 3 plus 8 square root 3. That's 18 square root 3. Solving radical equations. Step 1. Isolate the radical, or one of the radicals if there are two. Step 2, raise both sides to a power. 2 for square roots, 3 for cube roots, and so on. Step 3, if there's still a radical left, repeat steps 1 and 2. Step 4, solve the resulting equation. And step 5, check the resulting solutions to see if they're extraneous. Example, solve. The square root of 3x minus 3 equals 3. First, we're going to square each side. That gets rid of the square roots, so now you just have 3x minus 3. 3 squared is the same thing as 3 times 3, and that gives you 9. You're to solve this equation, this linear equation. Add 3 to each side. 3x equals 12. Divide each side by 3. X equals 4. You're to check to see if it is real. To do that, we want to check each side individually. We have the square root of 3 times 4 minus 3. That equals the square root of 12 minus 3 equals the square root of 9. That equals 3. And the other side of the equation is just 3. 3 does equal 3, so that means that this is a real solution. Example 2. Solve x equals 3 plus 2 square root x. The first thing you want to do is isolate that radical. Subtract 3 from each side. Rewrite it. Let's square each side. So 2 times 2 is 4, and then square root x times square root x is just x. Now for this one, we have x minus 3 and x minus 3. We have it twice. You want to multiply that out. X squared minus 3x, and then plus 9. If you add these two together, you get minus 6x. Okay, from there, subtract the 4x from each side. And then you get x squared minus 10x plus 9 equals 0. You want to factor it. Two numbers that multiply to 9 and they add to negative 10. So we have x minus 1 equals 0 and then x minus 9 equals 0. So your two answers is x equals 1 and x equals 9. But before we determine if they're real or extraneous, we want to check each of those solutions. The first one, we're going to check x equals 1. So on the left side of the original equation, we just have a 1. Let's check the right side. 3 plus 2 square root of 1. 3 plus 2 times 1. 3 plus 2 equals 5. Well, 1 doesn't equal 5, so that means 1 is not a solution. 1 is extraneous. Now let's check x equals 9. So on the left side, we just have 9. Right side, 3 plus 2 square root 9. 3 plus 2 times 3. 3 plus 6, yes, that equals 9. 9 equals 9. So that means that 9 is a real solution. And if it just asks for solutions, you would only put the 9 on that. Solving quadratic equations. Solve x squared plus 5x plus 3 equals 0. Since this is already in the standard form, we can see that a equals 1, there's 1x squared here, b equals 5, and c equals 3. We want to make sure that one side of the equation has 0 before we identify A, B, and C. If there's only a variable there, it's a 1 for the coefficient. If there's nothing there at all, not even an x, then it would be a 0 for that coefficient. We want to use the quadratic formula to solve for our two roots. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Substitute the given values into the quadratic formula. So this step we want to substitute. This step, find discriminant. The discriminant is just a number inside the square root, the radicand. Next, simplify if possible. In this case, 13 doesn't need to be simplified. And then you would simplify the fractions, reduce it. And since it has a plus or minus symbol there, you have two answers, one where they're added and one where they're subtracted. Our two solutions is x equals negative 2 plus square root 13 all over 2, or x equals negative 2 minus square root 13 all over 2. Factor quadratics. Factoring quadratics when a is not equal to 1 using the AC method. Here's your example. 9x squared plus 6x plus 1. Okay, so a times c is equal to 9 times 1. That equals 9. We're going to write all the factors of 9. We have 3 times 3 and 9 times 1. Well, 9 plus 1 is not 6, but 3 plus 3 does give you 6. From there, we can break it up into 4 terms. Factor out the greatest common factor out of the first 2 terms. It's 3x. And divide those out to see what's remaining inside. 9 divided by 3 is 3. X squared divided by x is just 1x. And 3x divided by itself is just 1. The GCF of 3x and 1 is just a 1. Notice they both have a 3x plus 1, so we can factor that out of the whole thing. And notice that we have the same factor repeated twice. That means we can rewrite this as 3x plus 1 squared. Law of exponents. Here's your law of exponent properties. If there's no exponent there, there's really a 1. If you have a base raised to 0 power, it's going to equal 1 as long as that base does not equal 0. 1 raised to any power is going to be 1. We have our product of powers, quotient of powers, power of a power, more power of a power, and then more power of power, but this time we have a quotient in there. Alright, simplify 2x squared over 3 squared times 3y over x to the 4th power. You want to square the first term. So since it has it twice, we really could think of it like this. 2 times 2 is 4. X squared times x squared is x to the 4th. And 3 times 3 is 9. Rearrange it so that all the numbers are together, all the x's are together, and all the y's are together. There is no y in the denominator, so we'll just put a 1 there. Alright, so we have 4 times 3, that's 12. 9 times 1 is 9. Okay, we're going to use that property, x to the 4 minus 4, that equals x to the 0 power, that equals 1. And then y divided by 1 is just y. Okay, you want to simplify 12 over 9, divide each of these by 3, and you get 4 over 3. So this is your answer. This is your simplified expression. 4y over 3. Arithmetic series. The seats in the auditorium has 7 seats in the first row, with 1 additional seat being added to each side for each additional row. If there are 9 rows, how many seats are in the auditorium? So if we have a long time on this, we could actually draw out all the seats. Let's just draw out the first 2. So the first row has 7, and it says each additional row has 1 more seat on each side. So we're going to add 1 on this side and add 1 on this side. And then we have our 7 from before. So that's going to be 9 seats in the second row. In the third row, we're going to have 11 seats. Each time we're adding 2 more seats to that row. Now it says there's 9 rows, so we're going to do this 9 times. So we have 7 plus 2 is 9, then 11, 13, 15, 17, 19, 21, 23, 25. And then that's too many rows, so let's go ahead and erase this one. So that's 9 rows. We have the first row, second row, third row, fourth row, fifth, sixth, seventh, eighth, and ninth rows. From there, you just add those 9 numbers together. You should get 135. Now that is if you want to count them all up. There's also a formula for this. You will find the first term, which was 7, and then the last term, which was 23. Add them together, multiply by the number of rows, and then divide it by 2. Now to get the last row, if we didn't really know it and we didn't want to count up to it, you could also use the explicit formula. A of n equals a1 plus d times n minus 1, where d is the common difference, which is 2. A1 is the first row, which was 7. N is the number of rows. And that's how you could get that last number 23. Rationalize denominators. 3 over 2 square root 3 would not be considered in the proper form. So to rationalize it, you're going to multiply by the square root of 3 over the square root of 3, that unity fraction. This is to make it so that we have the square root of 9, which is equal to 3, which is no longer an irrational number. Two times 3, that gives you 6. Notice those 3's, they're the same factor in the numerator and the denominator, so they cancel, and so you're just left with the square root of 3 over 2. This would be considered the rationalized form. This is the proper form that it would have an answer in. Alright, if you continue the slides, you can see some more worked out problem videos from other people, and then you could try some more practice for the algebra section, or you can go to one of the other 3 domains of this math test.